So in the previous problem we have counted number of A's and number of B's in one method where we divided all the strings into four classes. One is even, even odd, odd, right? So now I am going to discuss some other method in which we can access the same language. So now again the problem is same. Let us say I wanted to count set of all strings, or I wanted to draw a DFA for set of all strings over A comma B in such a way that number of A's in W is even, which means if I take number of A's it should be even. If I divide the number of A's with 2, remainder should be 0, and number of B's in W should be even. So yesterday we have seen that I classified set of all strings into four classes. According to this problem we have four classes. One is number of A's can be even, number of B's can be odd, even odd, and then odd. We have seen those four. Now let us try to do it in a different manner using some other method. This is also called as cross product method. First thing is we want to count number of A's as well as we want to count number of B's. So let me draw it like this. Independently I am going to do. First thing is counting A's. I am counting A's. Capital A, B. So this is going to count 0 A's, 1 A, 2, 3, 4, 5, which is nothing but this state A represents even number of A's and state B represents odd number of A's. I am not going to count B's, so B's are going to be here. Okay, now I will count B's. Counting B's. Okay, so same, but then I am going to use different names. Let us say this is state C and let us say this is state D. 0 B's, 1 B, 2 B's, and number of A's I don't count, and the even number of B's is this. Now I want to combine these two. I am going to combine these two using a method called cross product. So first of all I am going to discuss this cross product method, and then I will be changing the problem and doing it in a other way. So let me discuss the cross product method now. So in the problem there are two independent DFAs and the final state is A and final state is B. So the cross product method goes like this. First write number of states in this. A comma B cross. Now write number of states in this, C comma D. This is going to give a cross product of this. So I am going to combine two sets. So I am going to get ordered pairs, and this ordered pair I am going to write it like this: AC, AD, BC, BD. I have four states: AC, AD, BC, BD. Okay. So since in the initial, now when I apply the cross product I got four states, and since in the initial diagrams A and C are the final states, here AC is going to be final state. I'll talk about it later. Okay. First of all we know that there are four states, so I'm just going to draw four states. One is AC, okay, and the other is AD, okay, and the other is BC, and the other is BD. I am drawing just four states. Okay, and now after drawing these states I should know the transition. For example, I should know what is the transition of AC on small a. In order to know this, go to the original diagram and see what A is doing. Capital A on small a is going to capital B, and capital C on small a is going to capital C. Therefore AC on small a is going to BC. So I am going to write it like this. Okay, so understand this. I have initially constructed the DFAs independently, and then I am trying to club them. It is also called as cross product method. So when I am trying to merge them, the diagram is going to look something like this. Though we know that there are 4 states, now I have to fill up the transitions. I'll take a state and then I'll see what is the transition I wanted, AC on small a. Therefore, I'll go to the original diagram and see what capital A is doing on small a and what capital B is doing on small a. So capital C is doing on small a. So I got that. I have to go to BC. Okay, and now AC, again AC on small b. Let us see what is AC doing on small b. So if you look at AC on small b, capital A is going to capital A itself, and capital C on small b is going to capital D. Therefore, AC on small b is going to AD. Fine. Now let us see BC. Let us talk about BC. BC on small a, B on small a is going to A, and C on small a is going to C itself. Therefore, BC on small a is going to AC. BC on small a is going to AC. Okay. Now what about BC on small b? Capital B on small b is going to B itself, therefore B, and capital C on small b is going to capital C on small b is going to D. Okay. So it is going to be like this. So BC on B is going to BD. Okay, so BC is done, AC is done, BC is done. Now let's take AD. AD on small A on small a is going to B, and D on small a is going to D itself. Therefore, AD on A is going to BD. Right? And now AD on B. A on B is going to A, and D on B is going to C. So AD on B is going to AC. Fine. So AC, BC, AD are done. Now let's talk about BD. BD. BD on A. So B on A is going to capital A, and D on A is going to capital D. So BD on small a is going to AD. BD on small a is going to AD, and BD on small b. Look at this. BD on small b is going to B itself, capital B, and D is going to C. So BD on small b is going to BC. So that is how I fill it up. Now if you can compare the previous question and this question, it looks exactly the same. The diagram looks exactly the same, and in fact AA is nothing but even number of A's and even number of B's. AC is nothing but even number of A's and even number of B's. And now BC is nothing but odd number of A's and even number of B's. And AD is nothing but even number of A's and odd number of B's. And this one is nothing but odd number of A's and odd number of B's. So according to the problem, both the A's and B's have to be even, therefore AC has to be the final state. Or even if A and C, in the original diagram A and C are the final states, so whatever is the combination, I am going to take it as the final state. And now this model can be extended to any number of questions. What are the other possible questions they can ask us is, the question can even be, here let us say they have asked for AND, which means if they ask for number of A's and number of B's, if the question is number of A's is even and number of B's is even, then we have seen that EE is the final state. Only one final state, which is E, or in this case AA. In the previous question E, both are same, right? The question can even be number of A's is even or number of B's is even. What if this is the question? Which means either the number of A's can be even or the number of B's can be even. So see this, first one is E should be the final state, definitely. Why? Because number of A's and number of B's both are even, and moreover EO can even be final state because number of A's is even, and OE can even be final state because number of B's can be even. So in this case, if I have OR, I will get more than one final state. Only state which will not be a final state in this question is O, which means odd odd. Odd odd should not be there in this case, because if the string contains odd number of A's and odd number of B's, it is neither even number of A's or even number of B's. So this question can be extended to any level. You can use your imagination and frame many other questions, but for now this is enough. And this is one method of forming the answer. I will just tell you one more method in which we can even solve such questions. That will be the easiest way. And one point worth noting here is the cross product method. If a automata, a DFA, contains n number of states, and if other DFA contains m number of states, then the final DFA which is obtained by cross producting of these two will contain n cross m, n into m number of states. Which means if one automata contains 2 number of states and if the other one contains 2 number of states, then the cross product is going to contain 4 number of states. So similarly, you can extend this question to any number. For example, how I can draw it without using this cross product method is, if you observe this question, just observe this diagram, just focus on this diagram. Okay, so if you see this, it is going to be number of A's are counted horizontally and number of B's are counted vertically. Just observe this for some time. Number of A's are counted horizontally, right? And number of B's are counted vertically, which means like this. So I can even extend this question to the next level also, which means you can even check number of A's and number of B's to be let us say number of A's is multiple of 3. Let us just change the question, or let me just explain this with the same one with a different diagram. Let us say I want to draw a diagram in which number of A's have to be multiple of 2 and number of B's have to be multiple of 2. Then the diagram is going to look something like this. A's are being covered horizontally, counted horizontally. A's are being counted horizontally and B's are being covered vertically. B's are counted vertically. Right? You can directly draw it like this. Maybe I'll take a different question and I'll explain you this method of drawing it, which is very easy.